Professor Nilesh Kharate, Associate Professor, Department of Mechanical Engineering, Maratha Vidya Prasar Samaj, ABT College of Engineering, Nasik. I welcome you all for this lecture on the topic optimization. In this chapter, we are going to cover the following points. First point is optimization, that is a definition of optimization. Second is types of optimization, that is how the optimization problem can be classified. Third one is linear optimization, that is what is linear optimization or linear programming, and then where it is used. And point is the various basic steps used in linear programming. Fifth point is construction of linear programming model, that is how to construct the linear programming problem. And the last one is the various methods which are available to solve the LP problem, that is linear programming problems. This is all about the content which we are going to cover with this video. So let us move forward. First is optimization. What is optimization? It is the act of obtaining the best results under the given circumstances. That is, to obtain the optimum solution for the given problem. Most of the optimization problems are having more than one solution. So optimization techniques are used to find out the best results amongst these available solutions. That is, here we are going to obtain the optimum solution for the given problem amongst the available solutions. Simply, optimization can be defined as the science of determining the best solution to certain mathematically defined problems. This is how optimization can be defined. It is simply a method of obtaining the best results amongst the available solutions under the given circumstances, that is, under the given constraints or the limitations. Then next point is the type of optimization. Here the optimization problems can be classified based on the given function, that is f of x. And it is divided into three types. First one is linear programming, second one is quadratic programming, and third one is non-linear programming. In case of linear programming problem, both the function as well as the constraint equation, that is limitations, are linear. And that for quadratic programming, the function is quadratic, but the constraints are linear. The third one is non-programming. So let us see one by one. In that, first one is programming. First is linear programming. What is linear programming and where it is used? Linear programming. The basic problem of linear programming is to either maximize or minimize the, this is important, maximize or minimize the objective function. This is important. So we can say that linear programming can be used for solving the problems which is having either maximizing or minimizing the objective function. Now, if we consider a simple example of any business system or manufacturing firm, then it is obvious that for any business system or manufacturing firm, it is desirable to achieve the maximum profit or to minimize the manufacturing cost or the production cost or the production time. So in case of any business system, first try to understand the objective function. For any business system, the objective function is either profit. It is either profit or manufacturing cost or production cost, or sometimes it is manufacturing time required to manufacture the components. These are the objective functions for any business system. Now, when we use the linear programming for such a business system or manufacturing firm, then its objective function is either maximize the profit. It is either maximize the profit or minimize the manufacturing cost. Therefore, when we use LPP, that is linear programming problem, then the basic aim of such a problem is either maximizing or minimizing. So remember, linear programming problems are related to either maximizing or minimizing. Now, it is used in different applications such as business system, then area of different areas of economics, computer science, mathematics, etc. These are some of the applications of linear programming. The next is the basic terms which are used in linear programming. First and very important basic term is the constraint. As we all know, the constraint means the restrictions or the limitations on the decimal variable. Simple, it is restrictions or the limitations. What is constraint? Constraint means restrictions or the limitations on the decimal variable. Constraint defines the limit within which the output of the solution to a problem must be found. So here you have to find out the optimum solution for the given problem, considering all the restrictions and limitations on the decision variable. This is nothing but the constraint. Now let us see a simple example how to formulate the constraint equation. Here, example of a company is given. If for a company, see here, if for a company, machine shop capacity is T hour. The total machine shop capacity available is T hour, and it is going to produce two type of product. First one is P type, and second one is Q type. P product is of X number quantity. P product is of X number quantity, and Q product is of Y number quantity. And the production of P product with X number require I hour, and similarly Q product with Y number of quantities require J hour for the production. What is the constraint? Constraint is the I hours required to produce the P product of X quantity, and J hours are required to produce the Q product with Y number of quantity. These are the constraints. So how the constraint equation is to be formulated for the production of product P and Q? Simple. X product require I hour, therefore X into I plus Y product require J hours to produce, therefore Y into J, it should be less than or equal to T, and where T is the total shop capacity available. It should not be beyond the T hours. This is the constraint. By considering all these constraints, limitations, or the restriction, you have to produce the P product and Q product with X number and Y number respectively. This is all about the constraint, how the constraint equation is to be formulated. Within this constraint, you have to find out the optimum solution for the given company. Then next important term is objective function. Next important term is objective function. What is objective function? The word objective suggests the purpose, goal, or aim. And the aim in the linear programming is to achieve the maximum or minimum of the function. as we have already discussed. LP, that is linear programming, is used either to maximize or minimize the given objective function. Therefore, here objective function defines the purpose or goal or the aim, and the aim of linear programming is always to achieve the maximization or minimization of the function. Let us see a simple example. Suppose if we consider the same example in the above example, if P product with X quantities, P product with X quantities, X is the number of quantities produced for P product. It gives the profit of rupees M. It means that P product with X number gives profit of rupees M, and similarly for Q product and the quantity is Y, which gives the profit of rupees N. Then what is the objective function here? Here for this firm or the company, the objective function is to maximize the profit. Correct? Therefore, then the objective function is to maximize the profit, and the profit is for P product it is M, and for Q product it is N. So therefore the objective function can be written as total number of P products are X into it gives profit of rupees M. Therefore X into M plus total number of Q products are Y, and it gives profit of rupees N. Therefore Y into N, it is equal to maximum, or it can be written as X into M plus Y into N should be maximum, and it is denoted by capital J. Likewise, you have to prepare or formulate the objective function from the theoretical statement of the problem. So finally, we can write it as Z is equal to Xm plus Y into N, where X and Y are the number of quantities produced for P product and Q product respectively, and M and N are the profit for P product and Q product respectively for X quantity and Y quantity respectively. This is how the constraint equations are formulated, as well as the objective functions are formulated. Then next one is feasible solution, or sometimes it is also called as feasible regions. What is feasible solution? A feasible solution is a set of value. Feasible solution is a set of value for the decision variables that satisfy all the constraints in the optimization problem. We have already discussed that most of the optimization problems are having a number of possible solutions. Therefore, what is feasible solution? Feasible solution is nothing but it is a set of possible solutions or possible values, set of values. But it is important that every value should satisfy all the constraint equation in an optimization problem. Suppose for a problem, number of solutions are 5. These are the number of solutions. 1, 2, 3, 4, and 5. These are the number of solutions. The set of all these values are nothing but the feasible solution. The set of all these values are nothing but the feasible solution, and all these values must satisfy the constraint equation. This is one, then this one is second value, this one is third value, this one is fourth one, and this one is fifth one. These are the 5 possible set of values. And all these values are called as feasible solution. Then what is feasible region? The set of here, the set of here, the set of all feasible solution defines the feasible region of the As discussed earlier, optimization problem is having more than one solution. That is different solution values for decision variables, and such that it should satisfy all the constraints equations in the optimization problem. Simply, what is feasible region? It is the region which is bounded by the values of feasible solution. This is called as feasible region. The region which is bounded by the values of feasible solution. This is nothing but the feasible region for the given problem. This is the feasible region. This is different between feasible solution and feasible region. Sometimes it is also called as bounded region. It is also called as sometimes bounded region. The next important term is optimum solution. What is optimum solution? An optimum solution is a feasible solution. Optimum solution is a feasible solution where the objective function reaches its maximum or minimum value. As we all know, linear programming is used either to find the maximum or minimum of the objective function. Therefore, when we say the optimum solution is achieved when the objective function reaches its maximum or minimum value, either maximum or minimum value for the given object is nothing but its object, its optimum solution. It depends upon the type of function. If the function is profit, then it is always desired that profit we should have the maximum profit. If it is manufacturing time or manufacturing cost, then it is always desirable to have a minimum of manufacturing cost or the manufacturing time. All these are the optimum solutions. That is the value of objective function, either maximum or minimum. It depends upon the type of function. These are some of the important basic terms which are involved in linear programming. Programming. The next one is construction of linear programming model. How the linear programming model is constructed. Theoretical statement is given. So read this statement carefully. A company is producing a type of product within 40 minutes. If it requires 10 minutes for painting and final finishing. Similarly, it also produces B type of product, but it requires 30 minutes for production and 8 minutes for painting and final finishing. The production shop is available for 2000 minutes, and that painting shop is available for 3,500 minutes per week. The profit for the type of A product is rupees 15, and that of B product gives the profit of rupees 20. How many units of each type of product A and B should company B produce to maximize the profit? This is the statement of problem. From this theoretical statement, we have to construct the linear programming model. That is, here you have to formulate the objective function as well as the constraint equations. So very first step is write all the given data in the tabular form. So it is easy to formulate all these equations. So how it is written here, a company is producing two types of product A and product B. Product A and product B. Therefore, product A, product B. Product A required 40 minutes for the production. Therefore, 20 minutes for the production time for product A. And similarly for product B, it is 30 minutes. Production time required for B product is 30 minutes. If you read the next line, then 10 minutes are required for painting and final finishing of product A, and 8 minutes are required for painting and final finishing of product B. Product A gives rupees 15 profit and similarly product B gives profit of rupees 20. And the constraint is now it is important. The constraint is the production shop is available for 2000 minutes per week, and the top painting shop is available for 3,500 minutes per week. These are the constraints. These are the constraints. What is to be found? How many units of each product of A and B should company B produce to maximize the profit? To maximize the profit is the objective function. Here, the objective function for given company is to maximize the profits, and for that here we are going to find out the number of quantities of product A and B should that company B produce, so that it will get maximum profit. So initially, first prepare the table containing product A and B. Then let us assume X be the quantity. Let us assume X be the quantity of the product A produced and Y be the quantity of product B produced. Now the objective function. What is objective function? Here the objective function is to maximize the profit. It is already given there in the problem. So it is written as X is the quantity of A product, right? And X gives rupees 15 profit. Therefore, 15 into X plus Y is the number of quantity produced for B product, and it gives rupees 20 profit. Therefore, 15X plus 20Y is the maximum. This is your objective function. This is your objective function. You have to find out the values of X and Y. That is quantity of product A and B produced. This is the objective function. Then next you have to find out how the constraint equations are to be formulated. Now the constraints are production shop is available for 2000 minutes and the painting shop is available for 3,500 minutes. Now see here, product A requires 40 minutes for the production and product B required 30 minutes for the production. Therefore, and the total time available for the production shop is this much, 2000 minutes per week. Therefore, 40 into X. X is the number of quantity produced of product A. Therefore, 40 into X plus 30 into Y. If it is less than or equal to 2000, because here the maximum production shop available is only for 2000 minutes per week. Similarly, for second constraint, this is your second constraint. 10 minutes are required for painting and final finishing of A product, and 8 minutes are required for painting and final finishing of product B. And X is the quantity of product A, and Y is the quantity of product B. Therefore, here 10X plus 8Y would be less than or equal to 3500. This is called as the constraint equation, and this is your objective function. And now finally we can write the linear programming model for the given problem is Z is equal to 15X plus 20Y, which is subjected to these two constraint equation. 40X plus 30Y should be less than or equal to 2000, which is production constraint. And second equation, constraint equation, means 10X plus 8Y should be less than or equal to 3500, which is a painting constraint. This is all about how to construct the linear programming model. Then next point is methods to solve linear programming problems. Various methods are available to solve the linear programming problems. Those are, first one is graphical method and the second one is simplex method. Graphical method is a graphical approach used to obtain the optimum solution for the given problem. But it is used to solve the problem when the equation involves only two unknowns. Graphical method is suitable only when the problem contains two unknowns or the two variables. Remember, and the second one is the simplex method. It is iterative type method. It is iterative type method, which is used to find the optimum solution. And this simplex method is used to solve the problems which involves more than two unknowns or the variable. This is the difference between simplex method and graphical method. Graphical method is suitable only when there are two unknowns or the variables, and the simplex method is a iterative type method, and which is suitable when the equation involves more than two unknowns or the variable. This is how the optimization problem is formulated and can be solved with the help of these two methods. So in the next video, we will solve the numericals of linear programming with the help of graphical method. Thank you very much.